Oops. Alright, let's see what the local label assignment is on R4. And we do that with the show MPLS LDP. I want to see the bindings. And I want to see it for a specific prefix and the local binding only. Oh, well, look at this. Local binding is an implicit null. Cisco has freaking lied to me. This is so disappointing. Well, let's go ahead and see if anything has changed on the penultimate hop. Just going to do an up arrow. And as you saw before, we got the implicit null, so we were popping. That's the LFIB operation for this particular prefix. Let's see what we got now. Well, now that's interesting. Instead of popping local tag 18, what it's saying is that we're going to go ahead and swap it. And we're going to swap it with something called label 0. Well, I think I mentioned that earlier, that label 0 is actually the explicit null. It's a reserved, obviously, it's a reserved MPLS label. It's in the 0 to 15 range. And so even though R4 says that the local binding is an implicit null, it's actually advertising an explicit null to R3. So let's pop on over to R1 and let's do our trace route again and see what we get. And same. Oh, here we go. So booyah. We see that prior we had the implicit null. Now we've got an explicit null. Okay, so we've accomplished what we set out to do, and that is to break PHP. The results are a little underwhelming, obviously, and it does beg the question, what exactly is an explicit null and why would you use this? Like I said, this is going to be outside the realms of this video, but basically when you're doing PHP, in this case on R3, we've got a label coming, a packet with a label coming in, and we pop that. When we're using the PHP, we pop that thing off and we send it to the last hop as just an unlabeled packet. Well, one of the things with MPLS that you can set is you can set these experimental bits, and the experimental bits are just QoS. They're for your quality of service. The problem with PHP is that, you know, our packet's flying through the network, gets to the next to last hop router, and it pops that tag. So not only do we lose the label, but we also lose the experimental bits. So that packet gets to the last hop router as an unlabeled packet, and it doesn't have a mechanism for retaining those experimental bits. So what an explicit null does is it says, you know, go ahead and swap. And we saw that on R3. We're actually doing a swap operation from tag 18 to 0. Go ahead and swap out, you know, the incoming tag for this special tag, tag 0. Again, one of the reserved MPLS tags. And go ahead and when you do that, you're going to retain your experimental bits, your QoS. So that tag is actually going to hit your last hop. That packet is actually going to get routed to your last hop router of R4. It's going to come in with a tag of 0, and it's going to maintain those experimental bits. So if we pop over to R4, if we take a look at the LFIB, are we going to see labels with 0? Are we going to see packets that are bound to label 0? What do you think? I bet you know the answer. No, we don't. And the reason for that is that you can't really give a unique label to prefix binding with label 0. Again, this is a little outside what we're discussing right now, but think about it. If you've got, say you've got 50 loopback interfaces here, and remember that with directly connected and summarized routes, iOS is going to assign an implicit null. You know, it's going to say go ahead on the next to last hop router, pop this. So all we've done here is with that command is all we've done is replaced any implicit null advertisements with explicit null advertisements. So if you have 50 loopbacks or a ton of networks that are directly connected, you're going to have a ton of entries in your LFIB with a local tag of 0. And you can't guarantee uniqueness with that, so it's not used. So basically, we'll hit this in another video, but all you're using explicit null for is to retain those experimental bits so that they make it to the last hop router. Okay, so that's how you can effectively disable pentultimate hopping in a Cisco iOS environment. You're actually hacking it rather than explicitly disabling it. And like I said, we will go over experimental bits, QoS, traffic engineering with MPLS, and how the explicit null label fits into that. I just wanted to give you a quick and dirty to show you how you could emulate breaking PHP. It was kind of underwhelming. So anywho, I hope you enjoyed this, and I'll see you soon. Thanks. Bye.